We're going to shift gears a little bit. We're not leaving formulas behind for good, but we're going to shift over to talking about percent problems, okay? And percent problems, we do have a formula that we use. So we're still using that idea of formulas, but we're just shifting it to something very, very specific, okay? So this topic is using the percent formula. So what we need to know is there are three parts to all percent problems. There's the percent, the base, and the amount. And I'll refer to them for the next little bit as P for percent, B for base, A for amount, okay? So the percent, we write the percent in decimal form. To do this, we move the decimal to the left twice, okay? So you're going to be given the percent just in regular percent form. You do want to use it in decimal form in math. The base and the amount are easy to get backwards, and you need to make sure you have a firm understanding of the difference between the base and the amount. The base is the entire quantity being considered, okay? The amount is some portion of the base, and the way we get the amount is we multiply the base by the percent in decimal form to get the amount, okay? So again, the entire quantity being considered is the base. Some portion of that is going to be the amount, okay? And the way we get the amount, multiply the percent by the base, okay? So the percent formula is A equals PB. Just remember, P has to be in decimal form, okay? So example 4 says solve each problem. So what we're going to do is we're going to use this idea of the percent formula. We're going to plug in the information we have, and we're going to solve for the missing component. So one of the three pieces is going to be missing. We can find that. All right, so first we have what number is 9% of 50? This is not always going to be the case, but oftentimes when you're dealing with really basic problems like that, the word attached to of is the base. The word attached to is the amount. Now, this is not tried and true. This is not set in stone. There could certainly be situations where this varies a bit, but you can kind of use this as a general guide. So for part A, we're looking for some number that is 9% of 50. 50 is the entire quantity being considered here, and we want 9% of that. So we're looking for the amount. That number that's missing is A, the amount. P is always going to be obvious. So 9% is going to be our percent. And then 50, we're looking for 9% of 50. 50 is the base. So we're going to plug these numbers into the percent formula, and we're going to solve for A. So A equals 9%. We can't write 9% though. We have to write it in decimal form. So we're going to take 9 and we're going to move the decimal to the left twice, which makes it 0.09. And then we're going to multiply that by the base, which is 50. Okay? And you could certainly use a calculator. Some of this you can do by hand if you want, but you can use the calculator. Just make sure you show your steps. So we want to take 0.09 times 50, and I get 4.5. So A is 4.5. So we could change this sentence to say 4.5 is 9% of 50. And if you think about that, 9% is almost 10%. And if we took 50 and divided it by 10, we'd get 5. 4.5 is almost 5, so 9 is almost 10%. That makes sense. So a lot of times you can go through your answers and you can just kind of check them realistically to see if it makes sense, okay? But there's a situation where we use the percent formula and we found the amount, okay? Part B. We have 9 is, so we're saying the amount is 60% of what? Well, we don't know what that total quantity is. So this one is the exact opposite. We have the amount, we have the percent, we don't know what the base is. So 9 is 60% of some number, we don't know what. So we're going to fill this into the percent equation, or the percent formula is what I should call it. We get 9 equals 60%. Now remember, we want to write 60% in decimal form, so we move the decimal to the left twice, which makes 60.60 or just 0.6. And then we want to multiply that by the base, which is B, okay? Now this one's a little different. We're going to have to do a little bit of algebra. So this is the kind of like the classic multiplication property of equality. We have a constant equaling some variable term. So I've got 0.6 times B. I want to get B alone. And the way I undo multiplication is with division. So I'm going to divide the right by 0.6 to get B alone. But if I divide the right, I have to divide the left. So I'm also going to divide 9 by 0.6. Well, on the right, 0.6 divided by itself is 1. 1 times B is B. And I always write my final answer with a variable on the left. And now using a calculator, I do 9 divided by 0.6, and I get 15. So we could change this statement to say 9 is 60% of 15. And that makes sense because if we took 15 and divided it by 2, we would get what, 7.5? 60% is more than 50%. So 9 is a little bit more than 7.5. So that kind of makes sense. So just kind of get general number sense kind of working in your head again. Okay. So again, 9 is 60% of 15. All right. Now, part C would be the hardest example of this. Part C, we have the amount and the base. We don't have the percent. And so you really have to have a firm understanding of what the amount and what the base are. Okay. So what percent is our percent? We then have 18. Well, I just put B, not P. Hold on. This is P. Now we have 18 is some percent of 50. This is where the of and the is can really come in handy. Now, again, this is not tried and true. This is not set in stone. This does not always work. But in a really basic statement like this, the is and of are going to be really big hints. So we have 18 is, the amount is some percentage of the base, 50. So in this case, 18 is the amount, 50 is the base, okay? So we're going to put this into the percent formula. So I know that 18 equals P times B, so P times 50. Now I want to get the P alone, okay? The issue is P has been multiplied by 50. Well, how would I undo multiplication? I would divide. So I'm going to divide both sides by 50. I have to do both sides. If I multiply or divide one side, I have to multiply or divide the other side. On the right, 50 divided by 50 is 1, and 1 times P is P, okay? And I'm going to go ahead and write the P on the left. And then 18 divided by 50, you can do that on your calculator. 18 divided by 50, I get 0.36. And now hopefully you're like, oh, wait a minute, this is weird. Because remember, in the previous two examples, we plugged P into the formula as a decimal. So if you're looking for P, you're going to solve and get P as a decimal. We need to convert this to a percent. So if we take a percent and turn it into a decimal by moving the decimal to the left twice, hopefully it makes sense that we would take a decimal and convert it to a percent by moving the decimal to the right twice. So to go from percent to decimal, you go to the left twice. To go decimal to percent, you go to the right twice. So we move the decimal twice, and this tells me that P is 36%. So I could say 18 is 36% of 50. All right. So make sure you have just a general understanding of the amount and the base. We're going to see in the next example, we're going to see a very specific type of percent problem. And then in another video, in another worksheet, we'll see a different type of percent problem. So there are two types of percent problems you are for sure going to see in this course. So make sure you have just kind of like a general understanding of the amount, the base, and the percent.